Hello and welcome to this introductory video on induction, Faraday's law and Lenz's law. In this video we're just going to introduce what induction actually means and how we can use it to infer something useful by applying Faraday and Lenz's laws together to understand the effect that induction actually plays in circuits and things like that. So induction is a really fascinating phenomenon that basically amounts to understanding things about what's going on with flux. So we introduced the concept of magnetic flux. That's just counting the magnetic field lines through some surface. It turns out that when you start changing the flux through a surface, that actually induces an EMF in that circuit. So if you've got a circuit loop sitting in a magnetic field and you crank up the magnetic field, or you decrease the magnetic field, or you change the orientation of the loop to change its area or its projected area in that field, all of a sudden what you will find is that it induces an EMF which results in a current through your circuit loop. So changing magnetic flux induces an EMF. That is what induction is. That is what we mean by induces an EMF. That as a result of the changing magnetic flux, you experience an EMF across your circuit. So again, our picture is that we've got some magnetic field, and sitting in it we have some loop. I'll make it circular this time. Okay. Maybe we have just one, maybe we have several stacked on top of each other. Maybe this thing is actually a coil. It's wrapped, so it's wrapped wound tightly, make several loops, all at the same sort of size, and let's say I have n of them. As I change either the projected area by rotating that thing or change the magnetic field, I will be changing the magnetic flux through all of those loops. Each one experiences the same change, and therefore each one will experience an EMF. I can actually just add all of those up. So the expression combining Faraday and Lenz's laws that describes what EMF I'm going to experience in this thing is simply given by minus n times d phi dt. N is the number of loops, because each loop fundamentally has a d phi dt, and the EMF is just related to that d phi dt. Taking the n d phi dt, that's Faraday's law, and Lenz's law is basically providing the minus sign. So the magnitude, again, just to be clear, is saying the faster I change the flux, the larger the EMF I create. Okay, and the more loops I have, the larger the EMF. That's Faraday's law. Lenz's law tells me that there's a minus sign, and that minus sign is very, very important. The minus sign tells me something fundamental about the universe. So we know that everything in the universe tends towards the lowest energy state. Another cool feature of the universe is that it really doesn't like change in general. Okay, just like Newton's laws tell us that objects like to keep doing whatever they're doing unless there's a force, the universe doesn't like changes in magnetic flux either. And that's what the minus sign there is telling us. That in order to create this thing, I need to set up a field which counters the change. All right, that's what that minus sign means. So it's going to oppose the change in the flux. So if this is a magnetic field out of the board, which it is, and if that magnetic field is increasing in strength, then I have an increasing flux out of the board. So if I want to counter that increasing flux out of the board, I need some flux into the board. To create that flux into the board, I use my right-hand rule and determine the direction of the current